Hello everyone, welcome back to my math channel MathWeb. In this video, I will answer you question number 8 from Pearson Edexcel A level exam for Mechanics 1. This exam is taken in May 2024. Paper reference code is WME01/01. Let me read the statement for this question. One end of a light inextensible string is attached to a particle A of mass 2m. The other end of the string is attached to the particle B of mass 3m. A particle A is held at rest on a rough plane which is inclined to the horizontal ground at an angle alpha. Tan alpha equals to 5/12. The string passes over a small smooth pulley P which is fixed at the top of the plane. Particle B hangs vertically below P with the string taut at height h above the ground as shown in the figure 4. The part of the string between A and P lies along a line of greater slope of the plane. The two particles, the string and pulley, all lie in the same vertical plane. The coefficient of friction between A and plane is 11/36. Coefficient of friction is represented by mu. The particle A is released from rest, begins to move up the plane. Show that the frictional force acting on A as it moves up the plane is 22 mg/39. We need to prove that the force of friction equals to 22 mg/39. As the plane is rough, so there is a force of friction here. Look at the figure. When object A is released from rest, B is moving downwards and A is moving up the plane. If A is moving up the plane, the forces acting on the particle A, we should draw them all. Let me draw all the forces acting on particle A. One force is acting up the plane, that is tension T. For sure it is tension T here and also tension T here. Okay, and for particle B, there is another force that is acting downwards. For sure that is its weight force, so we can represent it as 3 mg. Similarly, we can draw the weight force for particle A that is acting vertically downwards like this. Okay, and also there is a normal reaction that is acting like this one. So this is a normal reaction, it is always making 90 degree with the plane. This one is the weight force, so weight is 2 mg for particle A. Here this is a normal reaction. We will represent it as R. Geometrically we can prove that this angle and that angle, the vertical, the weight that is making with this line is always equal. These two angles are always equal. You will make like this. Okay, and here we can resolve the weight force. It resolves the weight force into its components. One is the vertical component and other is the horizontal component. So these are two components for this weight force. The side opposite to the angle is always vertical component, so we can say this component is 2 mg sine alpha, and the horizontal component is this one, so this component is 2 mg cosine alpha. So in these questions we always resolve the force like this. The weight force is resolved like that in all these questions. When the particle A is released from rest, so for sure it will move up the plane and particle B is moving down the plane. So this is moving vertically downward, so acceleration will be this way, and here the acceleration will be like that. You know, the plane is rough, therefore there will be the force of friction. So usually it is taken opposite to the motion. So this force is the force of friction, and the formula of force of friction is mu r. F equals to mu r. So you can use this formula to find the force of friction here. The first part, we need to prove that this force F is equals to 22 mg/39. Okay, I'm solving it here. For first part, I'm using the forces for particle A, for A only. You can take the forces that are perpendicular to the plane, like this way forces. There is one force is acting upward like this, one force is acting this way, and other force opposite to this one is this component. You know, these two components, because there is no motion, so in this way we can keep these two components equal. Okay, upward component will be equals to downward component, so these two components are equal because there is no motion along this line. So we can write as R equals to 2 mg cosine alpha. Also, I forget to tell you, whenever the tan is given there in the question, best thing, draw a right triangle, any right triangle like this. Okay, and here is alpha, the side opposite to the angle. So this is 5 and this is 12. So by Pythagorean theorem, we can find the hypotenuse. That will for sure that will be equals to 5 square plus 12 square root of this one. Okay, and that will be equals to 169 square root, and we get hypotenuse as 13. Like this, after finding hypotenuse, you could easily find the other two trigonometric ratios. One is sine alpha. For sure, that will be equals to 5 over 13. That is opposite over hypotenuse. And cosine alpha equals to 12 over hypotenuse. Hypotenuse is 13. So these are two other trigonometric ratios. You have to find these values. And we can use this value here now. Cosine alpha is given, and that is equals to 12 over 13. So you could get the value of r from here. So it will be 2 mg cosine alpha. Cosine alpha is 12 over 13. Hopefully you understand it. And you can simplify this one as well. So 12 multiplied 2 is 24 over 13 mg. And you know that f is always equals to mu r, f max. So plug in the value of mu and r. Mu is there, it is already there, that is 11 over 36. 11 over 36, and plug in the value of r. Okay, this is the value of mu, and now plug the value of r, that is 24 over 13 mg. So solve these two fractions by using calculator. For sure your calculator will give you this answer, that is 22 mg over 39. mg we will keep as is and solve these two fractions by using calculator. So it is as required. So force of friction, we prove that it is equals to 22 over 39 mg. So this is the answer for first part of this question. Hopefully you understand. If you are not understanding, please, any topic, any step, write in the comment box. Okay, I will try to explain it again. Let's move on to the next part. For second part, write down an equation of the motion for B. Look at the figure again. You have to consider this part only, because it is moving downwards, you know, and there is acceleration. So this is my way of solving these type of questions, you know. For particle B, I always write a net force formula by Newton's second law of motion. Net force is equals to ma. This is the standard formula for finding the net force, because the particle B is moving downwards. So the downward force is greater than T. Okay, so you can, because it is moving downwards, so 3 mg is greater than T. So how could you get the net force? 3 mg minus T, and the mass is 3m for this particle. So what is the net force here? 3 mg minus T. Let me tell you how to find the net force. You know, if you are applying here 100 Newton force on the right side, okay, if here you are applying 100 Newton on the left side, so object is not moving. So net force in this case is 0. And here same way, if you are applying here 100 Newton and on the other side you are applying like 60 Newton, so how could you get the net force? Smaller force is subtracted from the greater force. Okay, this is the rule of finding the net force. So that is 100 minus 60, so it is 40 Newton. Okay, so this is the way of finding the net force. You should know this one. Okay, it is very simple. And mass of particle B is 3m. So we will use here 3m and keep A as is, because you are going to find it. Okay, so from here you could get the equation of so this is enough. I think it is enough. It is of 2 marks. Maximum you can do, you can get the value of T from here. That's it. You can move this one here and move this value there. Okay, T negative will become positive and this will be minus here. Okay, so T will be equals to 3 mg minus 3 ma. So this is the equation of the motion for particle B. So second part is done. Let's move on for the next part of this question. Show that the acceleration of A immediately after its release is 1 over 3 g. We need to prove that the acceleration for particle A is 1 over 3 g. The string is inextensible and we are assuming that the tension on either side of the pulley is remains same. It is equal. So acceleration will be equal for both particles, as B is moving downwards or A is moving up the plane. Look at this diagram. we will use a net force because this particle is moving up the plane. So net force, the component that is acting this way will be greater than the components that are acting down the plane, downwards. So look at the figure. There are two components that are acting down the plane. One component is this one, F equals to mu r, and other component is this one. Okay, these two components are acting down the plane, and T is the only component that is acting up the plane. So the net force for this particle A will be T minus mu r minus 2mg sine alpha. You understand it? Hopefully. So just consider this part of the diagram and apply the same rule what I applied there in second part of this question. Now for C, now we are using the net force formula, Newton's second law, for particle A only. Net force formula is ma. Therefore the net force will be equals to T minus the two other components. One is the F is the force of friction, minus 2mg sine alpha. Okay, and mass is 2m, therefore we have to use here 2m and A. Okay, so one component is T and other two component is F and 2mg sine alpha. Okay, so we will subtract these two components. F we already got it in the first part. We got it F 22 mg over 39. So you can use that value here. Now substituting the value of T and F from previous parts. T we just got it in the previous part, that is 3mg minus 3ma. 3mg minus 3ma, and F we got the answer in first part, that is equals to 22 over 39 mg minus 2mg sine alpha. Sine alpha, I told you here, better you draw the diagram and get the hypotenuse and find the ratios. So here we are using the values of these ratios. So sine alpha is 5 over 13. So sine alpha is 5 over 13 we can use here. And 2m A. M is common throughout, so you can cancel it. M is cancelled throughout. Okay, you are dividing by M, and the rest we will simplify. So it is 3g minus 3a, 22 over 39g, minus 2 multiplied 5 is 10 over 13g, equals to 2a. We want to get the value of a, so better you just move this value to the right side to make it positive, and it left with 3g minus 22 over 39g minus 10 over 13g, equals to this 3a will be added to the other side, so it will be 5a. In your calculator you will write like this: 3 minus 22 over 39 minus 10 over 13. You will write these numbers like this in your calculator. You will get the answer as 5 over 3. Your calculator will give you this answer. So on the left side, so answer will be 5 over 3 g equals to 5a. So 5 is cancelled from both sides. You are dividing both sides by 5. Therefore acceleration will be equals to 1 over 3 g. So this acceleration is as required. Got it? We need to prove that acceleration is 1 over 3 g. So part C is done. Now let us solve the last part of this question. In the subsequent motion, A comes to rest before it reaches the pulley. Find in terms of h the total distance traveled by A from when it is released from the rest to when it first comes to rest again. For the last part of the question, look at this diagram. When B travels the distance h, A is traveling the same distance h here along the plane. Okay, when B reaches here, it is also traveling h along this line. So actually there is two parts of the motion for particle A. In first part is traveling with h and with this acceleration, but when it reaches over here, now it is not moving with the same acceleration. It is moving due to its momentum, due to its inertia, because it will not stop over here. Due to when the object is moving, it keeps moving, the law of inertia. Okay, it will travel a little more distance here due to its momentum, due to its inertia, we can say. Okay, so that distance you have to find as well. So this is the normal direction for this particle when it reaches at this position. This is the first part of the motion. Here there is no tension here. It travels a further distance. Let's say that distance is x as well. So there is two parts of the motion. First part, it is traveling h. In the second part of the motion, but with the different acceleration, it is traveling x. Okay. So first of all, let us solve for the first part of particle A. First part of the motion. First part of motion. In first part of the motion, you can apply here SWAT, SUVAT. The distance traveled is h. U at this position, speed was 0, initial speed was 0, and final speed we can find over here. We could find, and acceleration we already found it, that is 1 over 3 g. In this part of the motion, acceleration is this one. Now three things are known. We can say h, 0, and 1 over 3 g. We can apply, this is for particle A, we are using for particle A. First part of the motion, these things are given, and we can apply here this equation of motion. We know that when three things are known, the fourth one we could find. When it reaches at this position, what was the speed? That speed we have to find it in terms of h. So formula is u square plus 2as. Plug in the values. So u square, u is 0 plus 2 into 1 over 3 g. This is the acceleration, and distance covered by it is h. And we can find by taking the square root of this value. So it will be 2 gh over 3, the square root of this. So this is the speed of the particle when it reaches at this position. Now for second part of the motion, again we can write the things here. Let's say they are S, U, V, A, and T. Now here we have S, we don't know, let's say that is x. We need to find this x as well. You know the initial speed, when it reaches at this position, the initial speed will be this one, because when it reaches at this position, the speed was 2 gh over 3 square root. Okay. So for this part of the motion, when it is covering x distance, due to inertia, that will be 2 gh will be the initial speed. 2 gh over 3 square root will be the initial speed, and finally it will be 0, and this particle is not reaching to the pulley, so it will stop over here, and final speed will be 0 at this position. And acceleration, we don't know this acceleration as well. So to find this acceleration, first we will apply the net force formula. You know the formula, net force formula is MA, you know. Here for finding the net force, you have to resolve the forces, all the forces acting on this particle when it reaches here. The weight force is 2 mg, and this is alpha as well, and there are two components, you know that. One component is 2 mg sine alpha. There is no tension anymore here, you know, it is moving due to inertia. There is no other force acting on the up the plane. There are two forces acting opposite to the motion. One is 2 mg sine alpha, and other is here, that is F equals to mu r. So these are two forces acting opposite to the motion, and both forces will be negative. One is F minus F, and the other one is 2 mg sine alpha. The particle was moving this way, right? It is moving that way, and but these two components are reducing the speed, and when it reaches here, that speed becomes 0, and we will find the deceleration for this part of the motion. Okay, so mass is 2m for this particle, and acceleration you can find over here. We already found F in the first part, that will be the same, that is let me go back to the first part, 22 mg over 39. That the force of friction is 32 mg over 39. Okay, so we can write over here 32 mg over 39 minus 2 mg, and sine alpha, we know that sine alpha equals to 5 over 13. We already found that at the beginning of the question. Okay, so sine alpha is 5 over 13. 2 ma. M is throughout, so we can cancel m from all of them, and the rest of them we can simplify. So it is minus 32 over 39, the first part, and here it is minus 10 over 13. If you solve them together by using calculator or mentally, you can solve even. So it will be minus 4 over 3. So this, the left hand side is minus 4 over 3 g. There is g as well, so you don't forget this one. It will be 2a here. So the deceleration will be equals to 2 will be cancelled from both sides. So it will be minus 2 over 3 g. So this is the deceleration for this part of the motion. So this is the deceleration for this part of the motion. We can write over here that is minus 2 over 3 g. So this is the deceleration. Now you can apply the equation of the motion because these things are known now. This equation of motion, v square equals to u square plus 2as. Okay, here you will plug the values. You know the final speed is 0. Initial speed is there, that is 2gh over 3. 2gh over 3 square root, because it is a square here, so you will keep square here. Okay, plus 2 into the deceleration, that is minus 2 over 3 g. Minus 2 over 3 g. And the distance traveled for this part of the motion is x. This value is negative, so you can move this value to the left side. So it will be positive 4 over 3 gx. This square will be cancelled, square root will be cancelled with the square. So it left with 2gh over 3. G is cancelled from both sides. And also you can cancel 2 from both sides, so it will be 2, and 3 is cancelled as well. Therefore, x will be equals to, you know, this is 2 goes down, x will be equals to h by 2. Okay, therefore total distance traveled by a, we have to add these two distances. One is h and other is x. So this is the total distance traveled by a. We need to find that. And subsequent motion is this one. Okay, when it is moving through due to inertia. When it is moving due to inertia. Okay, so we can add both distances, h and h by 2, 3h over 2. So this is the answer for the last part of the question. Hopefully you understand each and every step. Still, if you have any doubt, any comment about this question, please write in the comment box. Thank you.